So today we're going to do solving exponential equations. So the type 1 is solving with written with the same base, and that's what we're going to do today. An exponential equation is one that has the variable, so the exponent, the variable typically x in the exponent. So your variable is in your exponent. So like 2 to the x was an exponential equation, right? Y equals, because the variable is in the exponent. Some exponential equations can be solved by writing the power on either side of the equation with the same base. If this can be done, we can then equate the exponents and solve the resultant equation for the variable. This can only be done once the power is isolated. If this cannot be done, a skill we learn later on in this unit is required. So later on, we're going to learn using logarithms if we can't, how to solve it if we can't get common base. So the first way I always look at this is if I gave you 2 to the x equals 2 to the 3, right? And then I said, what does x equal? Or I'd say solve, because solve always means determine what x equals. All of you always say to me, well, of course, x equals 3, Lepp. And you're right. X, 3, right? So if these bases are the same on both sides, we can set our exponents equal. So we can say x equals 3. So our ultimate goal for today is that we're going to try and get our bases on the bottom to be exactly the same. Those numbers down here, this 2 is called a base. We're going to try and get our bases to be exactly the same. And if we can get our bases on both sides to be one base and be exactly the same, we can just set our exponents equal to each other and solve for x. Very, very, very easy, okay? So our ultimate goal is to get common bases, one on each side, then we can set our exponents equal, okay? So here are our steps. Steps for solving for common base. Isolate the power if necessary or possible. So and then write each side of the equation with the same power. Equate the exponents. Solve the equation for the variable. Verify your answers, algebraically and graphically. So we can check these algebraically and we can check them with our calculator. So at first we're going to check them algebraically, and then the last half I'm going to get you to check with your calculator. So we're going to practice, okay? So first thing we need to do is get both the sides equal, okay? Same base. So I have 2x minus 1 equals 8. Now what we try and do is make them be the smaller base. We never try and make them be a larger base, so I don't want to make the 2 into an 8. I want to make the 8 into a 2. Now where the error lies is you guys try and find two numbers that multiply to give you 8. So you'll say 2 times 4. That is not what we want for this lesson. For this lesson, we need 2 to the exponent something to be 8. So I know 2 to the power of 2 is 4. 2 to the power of 3 is 8. That's what I want. I want the base to an exponent to equal that number, okay? Not 2 times 4. That's not helpful. I need the same bases. So I need to raise that base to an exponent to get the number. So please do not try and multiply two numbers together to get it. That is not helpful. We need the base to an exponent. So now I can say 2 to the x minus 1 equals, and 8 is 2 to the 3. Now, some people say cross off your bases. You're not crossing off your bases. You have 2 to the x minus 1 equals 2 to the 3. Last time we had 2 to the x equals 2 to the 3, so we could say the exponents were equal. Well, now, if we have 2 and 2, we can say x minus 1 equals 3. And that's our next step. Write your exponents equal once your bases are the same, because they must be equal. Then, I'm going to add 1 to both sides, and I get x equals 4. What's great about these is when you walk away from this question, you should 100% be able to give yourself a high five knowing you got this right, because you can check it algebraically and you can check it graphically. Like I said, we'll do the first half algebraically, and then we'll come back and check graphically. It shows you how to do it below. All right, so we're going to verify so that we can walk away knowing we got it right. When we verify, we always use the original typed question. Nothing we've touched, because not everything we touch turns to gold. So we want to use the original typed equation. So we did And now we're going to verify for x equals 4. So wherever there's x's, we're going to plug it in. 2 to the 4 minus 1 equals 8. Then we get 2 to the 3 equals 8. And then we get 2 to the 3 is 8 equals 8. Remember, when you verify, what's on the left stays on the left side of the equal sign. What's on the right stays on the right. And you just work your way down till both sides equal. Boom. We know it's right. Yes, we can walk away from this question knowing we got it 100%. Okay? We're going to come back to how to verify graphically after, because like I said, we're going to do those for the last half. Okay? So we're just going to verify algebraically for this page. So now I have 9 x minus 1, 27 to the x. So what people try and do is they try and turn the 27 to 9 times 3 so that they think they can make them both be base 9. You can't. Remember, you need to take the base and raise it to an exponent. Okay, guys? So we can't make these both be base 9. We're going to actually have to change the base of both of them. They're both base 3 functions. How do I know that? Because I know 3 squared is 9, and I know 3 cubed is 27. So the common base that I can make them both be is base 3. Okay? So that's what I'm going to do. So I'm going to go 3 squared in for the 9. And I still have x minus 1 is my exponent. Equals 27 is 3 cubed in brackets. And x is still my exponent. Use a darker color. Okay. Now, rules for exponentials. What you learned is when two exponents are touching, like the 2 and the x minus 1 and the 3 and the x, remember when they're touching, so they're attached by brackets, you multiply. So I'm going to get 3 to the 2x minus 2. So that's why I always put this x minus 1 in brackets so I don't forget to distribute. Okay? If not, people will go 3 to the 2x minus 1 and you're going to get it wrong every single time. You have to distribute it to the entire exponent. Equals 3 to the 3x. Now I'm happy. On both sides, I have the exact same base. I have a 3 and a 3. The moment I have just two bases that are the exact same, the next step, I am able to write my exponents equal to each other. So I get 2x minus 2 equals 3x. The moment you have an x on one side of the equation and an x on the other side of the equation, you need to get them to be friends. You need to get them together on the same side. So I'm going to subtract 2x. I'm going to get negative 2 equals 3x minus 2x is x, and I'm done. But remember, I don't want to be lazy. I want to always check it. I want to always verify because I want to walk away from this question knowing I got it right. Now I'm going to verify x equals negative 2 by plugging it back into the typed equation. So 9 x minus 1 is going to be negative 2 minus 1 equals 27 to the negative 2. So I'm going to get 9 to the negative 3 equals 27 to the negative 2. And some people will say, well, they're the same. Unless someone who is little can look at that and say, yeah, they look exactly the same. You haven't verified it. So they need to actually, some person who knows nothing about math needs to be able to come here and be like, yeah, your answer looks the same. So if I put 9 to the negative 3 in my calculator, and I press math, enter if I really want to do that, I'm going to get 1 over 729. Why does the 729 go to the bottom? Well, remember that when you have a negative exponent, like 9 to the negative 3, whenever you have a negative exponent, you can write it over under 1 and it becomes positive. And 1 over 9 to the 3 is 1 over 729. So that's why it pops to the bottom. So this one would end up being 1 over 27 to the positive 2, and 27 to the positive 2 is 729. And now someone who knows nothing about math can say 1 over 729 equals 1 over 7. That looks right. Okay? You need to get to that step where they actually look the same. All right. Gets increasingly a little more difficult. Rules. Okay? Let's look at a rule. If I have, let's say, 2 to the negative 1, okay? 2 to the negative 1 is the same. This is just getting you into knowledge for the next question. 2 to the negative 1 has nothing to do with the last question, so I'm put in box. 2 to the negative 1 is 1 over 2 to the positive 1, which is a half, okay? So whenever you have 2 to the negative 1, that's the same as a half. The same thing is 1/2 is the same as 2 to the negative 1. So if I had 1/9, I could rewrite that technically by bringing, this 9 has an exponent of 1 currently. If it doesn't have anything, its exponent is 1. I could bring it to the numerator and make it be 9 to the negative 1. Okay? So whenever I have a fraction, I can actually bring that bottom denominator up and raise it to a negative exponent, and then it's no longer a fraction. Okay? So when solving common base, a lot of the time, if you can get rid of the fraction, you do, by just raising it to the negative power. If you don't believe me, go 4 to the negative 1 in your calculator. It's going to give you 0.25. And what is 0.25? A quarter. So it's just taking that 4 to the negative 1 and dropping it. All right. So we have 16 equals 1/2 x plus 4. The very first thing I'm going to do is change that 1/2. So I'm going to go 16 equals, and instead of 1/2, this is 2 to the positive 1. I'm going to bring it up here and make it be 2 to the negative 1, which if you don't believe me, type 2 to the power of negative 1 in your calculator and it will give you 0.5. And type a half into your calculator and it gives you 0.5. They are the same. So I'm going to get 2 to the negative 1, and then in brackets, I'm going to put x plus 4. So I remember to distribute that negative 1 to both the x and the 4. So I'm going to get 16 equals 2 to the power of negative 1 times x, which is negative x, negative 1 times 4, which is negative 4. And now I'm back to a question like I had before. So if you can get rid of that fraction, then you can get back to common base questions like we did before. So I have base 2 and I have base 16. Remember, we always try and make it be a smaller base. So we're not going to turn the 2 into a 16, but we can turn the 16 into a 2. When we have the base of 2, guys, you can't change 2 into anything else. So you're going to have to hopefully change the other side into base 2. So 2 squared is 4. That's not helpful. 2 cubed is 8. Still not helpful. 2 to the 4. I have a dead zone on my iPad. 2 to the 4 is 16. That is helpful. Some of you will go 2 times 8. Not helpful. Remember, you need to make it be a base to an exponent, or we can't make common bases. So for 16, I can replace it with 2 to the 4. So I'm going to say 2 to the 4 equals 2 to the negative x minus 4. And now, base and base are the same, so I can set my exponents equal. 4 equals negative x minus 4. And now we're just solving like we did in numerous years math. Add 4, add 4. 8 equals negative x. Divide by negative 1. X equals negative 8. Now, remember, we don't want to walk away until we've proven that we've gotten it correct by verifying algebraically. 16 equals 1/2. Sorry, I want to write verify, but I'm running out of room. Okay. 1/2 negative 8 plus 4. 16 equals 1/2 to the negative 4. 16 equals 16. 1/2 to the negative 4 is the same as saying 2 to the positive 4, which is 16. And we verified it. And now I can walk away from this question knowing I got it 100% correct. D. This is where people get stuck. They're like, oh no, I can't make 5 ever be base 2. So what do? You try and multiply these. The first step, you guys will go 10x, 10 to the power of x. You cannot do that. You can only combine bases if they are the same, guys, by multiplication, okay? You can't do that. So the moment that this 2 has a little exponent x on it, this 5 can't join it. Please remember that rule, or these are going to be kind of quite awful, actually. So instead of making the 5 join the 2, which you can't because the 2 has an exponent, okay? You can't put them together unless they have the same base. Instead of putting those together, stop yourself and be like, okay, I know I can't do that because that's a rule that I was taught. I cannot put those together. When one of my bases has an exponent, I cannot combine these two numbers. I cannot write 10 to the x. Okay, I can't do that. That's a rule. So then I have to think in my head, well, what can I do? Well, we can do past math that we did way before. What did we do before? Well, we divided the 5 over. And why can we divide the 5 over, but we can't multiply with the 2? We can't multiply the 5 with the 2 because the 2 has an exponent, right? But we can divide the 5 over because the 40 doesn't have an exponent. So these two numbers can go together. They don't have an exponent. We've done that before. That math was perfectly fine. So think, can't put the 5 with the 2 because the 2 has an exponent, but I can divide the 5 over with the 40 because the 40 does not have an exponent. So now I have 2x equals 8. And guess what? I started off basically the same thing up here. 2x equals 2 to the 3. 2 to the 3 is 8. So even though this question looks substantially harder, it's very similar to the example I showed you at the very beginning. So 2 to the 2 is 4, not helpful. 2 to the 3 is 8, helpful. And remember, I know, that's a 3 even though it does not look like one. I know that it has to be base 2 because the moment one of them is base 2, the other one, if it's going to become base, has to be base 2 because I can't turn 2 into anything else. So I get 2 to the x equals 2 to the 3, and now my bases are the same. So now I can say x must equal 3. And then I'm done. Wait, no, I am not. Remember, I want to walk away from these questions knowing that I got it 100% correct. So I'm going to verify x equals 3. So I'm going to go 5 times 2 to the power of 3 equals 40. Remember, when you verify, you put it back into the typed equation, which was the very first equation before I did the divided by 5. Then I go 5, and I have to exponents first. So 2 to the 3 is 8. 5 times 8 equals 40. And then people will stop and they're like, yep, it matches. Remember, you have to have someone who knows no knowledge of math to say, yeah, that actually matches. So we have to go one more step still. 5 times 8 is 40 equals 40. Now, my daughter in grade 3, I don't even remember what grade she's in, would say, yeah, they match. And we'd be like, boom, we're good. Okay? All right. Now, how do we do this one? 6 power of 2x minus 3 equals 1. Well, whenever you have an equation, an exponential equation equal to 1, you can make common base. Why? Because any base, so in this case 6, to the power of 0 equals 1. So the moment one of your sides of your equation equals 1, you can just say, awesome, I can make that a common base with the other side. So I'm going to go 6 to the power of 2x minus 3 equals, instead of 1, I'm going to go 6 to the 0. And now I have the same base, so I can go 2x minus 3 equals 0. Add the 3. 2x equals 3. Bad choice, can't barely see the difference. Divide by 2, x equals 3 halves. Now I want you to verify this with your calculator, okay? The steps are on the previous page. So to verify graphically, you take your original. You're going to go 6 to the power of 2x minus 3 equals 1. That's the original. Now what you're going to do is you're going to put this equation into y1. Now to type that in, you're going to go y1 equals 6 to the power of bracket 2x minus 3. And this little exponent button is right by your clear. So if you go clear and you look below, it's the little exponent button. It is essential, if your calculator does not bump the exponent up, that you put 2x minus 3 in brackets. Now the other side of your equation, you're going to put into the y2. And then what I always do is I go zoom 6. And the reason why I'm going to do that is because I don't know where any of your calculators, who's touched it last or anything. And zoom 6 just sets it back to that standard negative 10, 10, 10, 10 window. So at least we have a place to start. Okay, so now you'll have two graphs. You're going to have the 6 to the power of 2x minus 1 graph on your calculator and the equation y equals 1. So horizontal line at 1. And then we just want to find out where they intersect. So we're going to put the left side into y1, the right side into y2, and then we're going to go second, trace, 5, intersect, and then we're going to go enter 3 times. So we're going to go enter, enter, enter. We're going to press that button 3 times. Okay, and then we're going to look at the x. And if you look at your x right now, it's at 1.5. And what is 1.5? The same as 3 over 2. Now, if you want to turn that into a fraction, that 1.5, you can actually go second mode, get out of your screen, and then go X, the X button, math, enter, enter. If you want to learn that, you can always ask me, and we can meet on Google Hangouts Meet, and I will teach you how to do that as well. If you are confused at any point in time and you can't get x equals 1.5, because we don't care what the y is after the intersection, please message me and I'll go through the steps one by one with you, okay, till we get it. But these steps work. So y1 equals 6 to the power of 2x minus 1, y2 equals 1. I just pressed zoom 6 so that I got you guys back to your standard window. And then you go second trace, 5, intersect, enter 3 times. Now, if it gives you an error code, that's probably because your x max isn't big enough. So I'll often just change my x max to be larger and then go over the steps again. Second trace 5, enter, 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 and I'll get an answer. With this x being small, being 1.5, you guys will all get it. Okay, so we're going to check with our calculator for the next ones. And if it isn't working for you, don't freak out. Just email me and I'll meet up with you and we'll do it really quickly, okay? But you can try this on your own first. But if it doesn't work, don't worry, just email me. All right. Once again, we have a fraction. So I'm going to bring that 81 up. It's always my first step when I see one side's a fraction. So I'm going to go 27 to the x minus 2. And then I'm going to go 81 to the negative 1. That's how I bring it up. But I still have my exponent, which I'm going to put in brackets so I don't forget to distribute. I'm going to get 27 to the x minus 2 equals 81 to the negative x minus 3. Now what base can I make them both be? Base 3. So 3 to the power of 3 is 27. Then I have x minus 2 in brackets. 3 to the power of 4 is 81. And then I have negative x minus 3 in brackets. Now, I'm going to go 3. And I'm going to get 3x minus 6. I distribute that 3 through, so 3 to the x, 3 times negative 2 is negative 6. And then I get 3 to the negative 4x minus 12. And now my bases are the same, so I can set my exponents equal. 3x minus 6 equals negative 4x minus 12. If you have 1x on one side and 1x on the other and you're sitting trying to figure out what to do next, move one of them. It doesn't matter which one. I'm going to move the 4x because it's negative, that's all. Could I have moved the 3x? Absolutely. So I'm going to add 4x to both sides. I'm going to get 7x minus 6 equals negative 12. Then I'm going to add 6 to both sides. And I get 7x equals negative 6. And then I'm going to divide by 7. X equals negative 6 over 7. And I think I'm right. But I want to check. So what do? Take my original, 27 to the x minus 2 equals 1 over 81 to the x plus 3. This is my y1. This is my y2. So my y1 is going to be 27 to the power of bracket x minus 2. My y2, if you have alpha y equals enter and it gets you the fraction like I taught you earlier in the year, please use it. If you don't, I'm going to always show the method of one that works for every calculator, but it's always lots of brackets. So I'm going to go bracket 1 divided by, if I want to show it's a fraction, I can actually double bracket it, but I don't need to. Bracket 81 to the power of x plus 3 bracket. Now I technically don't need the 1 in brackets, but I like putting my numerator in brackets divided by denominator in brackets. Okay, then I do second trace 5. Trace button is up by the graph button. And the trace button, is right to the left of the graph button. Second trace 5, intersect. It's the last time I'm going to show these steps. Enter, enter, enter. So enter 3 times. Press the enter button. Like I said, don't worry. If you get it wrong or you can't get it to work, message me. I will help you. Negative 6 divided by 7. So in your x, you're always going to look for your x equals. In the x equals on your calculator, you're getting negative 0.857142857 and you're probably like, wait, that doesn't match. Well, go to your main screen and type negative 6 divided by 7 into it. They actually turn to the same decimals, so you know you are right. Okay? Then we have type 2, which are the more advanced exponential equations. With these equations, there are variables on both sides of the equal sign, so you cannot isolate the power. So before, in all the previous questions, we could always get, a lot of the time we could get just the variable by itself. Also, in the previous ones, I made it so that we had always one base to an exponent, one base to an exponent. Well, we're not going to stay that way, okay? So, and G we're going to leave for now. Don't worry about that. So we're going to look at 2a. So we have 2 to the x minus 3 equals 4 times 32 to the x. Now what we did last time, I told you the 4 can't multiply by the 32, right? I specifically said that. I told you that you couldn't put the 5 times 2 in that other equation. Here, over here, I'll show you. Oops. I told you couldn't do 5 times 2 over here because the 2 had an exponent, right? But we could divide the 4 over, or the 5 over, because 40 didn't have one. Well, that's not the case anymore. So I can't multiply the 4 times 32 because the 32 has an exponent x, right? We know that. I can't divide the 4 over in this time because the 2 has an x minus 3 exponent. Uh-oh. So I can't put the 4 times 32 together, I can't divide the 4 over. What can I do in this instance? Well, in this instance, I'm actually going to have to make the 2, the 4, and the 32 all be base 2. So I have 2 to the x minus 3, that's base 2. I can change 4 to be 2 to the power of 2. Times, I can change 32 to be 2 to the power of 5, actually. With an x outside. So now I have 2 to the x minus 3 equals 2 to the 2 times 2 to the 5x. Now, let's go back to grade 10. If I have, and even grade 9, if I have 2 to the 6 times 2 to the 3, they're both the same base. What do I do with the exponents? I actually add them. I would go 2 to the 6 plus 3, and I would get 2 to the 9. When do we multiply? When we just have them side by side like this. That would be 2 to the 18. But when I have 2 of the same bases being multiplied, I have to make sure I add those exponents. These exponents are going to be added, the 2 and the 5x. So I'm going to get 2 to the x minus 3 equals 2 to the, not 10x, guys, that's where you're going to error, not 10x. I have 2 bases that are the same, I add the exponents. So I'm going to get 2 to the 2 plus 5x. Okay? And now I have 2 base, only one on each side. So if I have 2 to the x minus 3 equals 2 to the 2 plus 5x, I can now set my exponents equal. So I can go x minus 3 equals 2 plus 5x. Once again, I have an x on both sides. So I'm not going to overthink it, I'm just going to move one of them. So I'm going to subtract x. So I get negative 3 equals 2 plus 4x. Then I'm going to subtract 2. Negative 5 equals 4x. And then I'm going to divide by 4. X equals negative 5 over 4. Okay. Then once again, what would I do to check it? Well, I would go y1 equals the left side. So 2 to the power of x minus 3 in brackets, because I always put my exponent in brackets. Unless it's raised, then I don't have to. Some calculators raise the exponent. And then y to the 2 equals, or y2 equals this one. 4, bracket, 32 to the x. And then I do second trace 5, math enter, enter, and I'm going to get negative 1.25, which is negative 5 over 4. So it works. B. I have a fraction. What did I tell you the first thing I would do if I have a fraction? I'm going to rewrite it. So currently it's 9 to the power of 1. I'm going to rewrite it as 9 to the power of negative 1, x plus 1, equals 3 times 81 to the 2x plus 1. Please do not go 3 times 81. You can't, because 81 is to an exponent. Please don't divide the 3 over. You can't, because 9 is to an exponent. So it has to sit like this. So we're going to distribute that negative 1 through. So I'm going to get 9 to the negative x minus 1 equals 3, 81 to the 2x plus 1. Now I'm going to tell you something, and I do it every single time so I don't make a mistake. If I see that I can't multiply the 3 into the 81, because the 81 has an exponent, and I see that I can't divide the 3 over to the 9, because the 9 has an exponent, I will put an exponent onto my 3 so I don't forget that it has one. So remember, the 3 actually has an exponent. Every number has an exponent. It has an exponent of 1, so I'm going to put that 1 in there. And trust me, that 1 is going to be very important. Okay, I have 9, I have 3, I have 81, and I need to make them all be the same base. What base I can make them all be is 3, and you'll get better at this as you practice. So 9 is 3 squared, negative x minus 1, and I'm going to put it in brackets so I don't forget to distribute. 3 is to the power of 1, and 81 is 3 to the power of 4. And the 2x plus 1 in brackets so I don't forget. Sorry. So, next step, distribute. So I'm going to get 3 to the negative 2x minus 2 equals 3 to the 1 times 3 to the 8x plus 4. Now, my next step was I have to get all these two bases together on this side. Remember, I have two bases that are the same and I'm multiplying. I need to add their exponents. So I'm going to get 3 to the negative 2x minus 2 equals 3 to the 1 plus 8x plus 4, which is 3 to the negative 2x minus 2 equals 3 to the 8x plus 5, because 4 plus 1 is 5. And now I have the same base. What can I do when I have the same base on both sides? Write my exponents equal. Let me do that over here. A frog in my throat today. I don't know what the heck's going on. Negative 2x minus 2 equals 8x plus 5. Once again, I have an x on both sides, so I'm just going to move one. So I'm going to add 2x. So I'm going to get negative 2 equals 10x plus 5. Subtract 5. Negative 7 equals 10x. Divide by 10. And x equals negative 7 over 10. And then I'm going to type it into my y1 and my y2, and I'm going to check it. Now remember, if you don't want to check it that way, you can also type negative 7 over 10 into the equation and see if left side equals right side. All right. Square root of 8. What the heck is that? So we go back to grade 10 again. If I gave you 8 to the half in grade 10, what did your teacher teach you to do? Well, they said this 2 down here, you drop it in front and it becomes the index. So it was how you could change fractions into radicals. So I'm going to get a square root function, and this 2 drops underneath and becomes the index. So I get a 2 in here, and then the 8 to the power of 1 drops underneath. So technically that's just the square root of 8, right? So if I gave you the square root of 16, not 16, let's say 12. Well, what exponent does 12 have? 12 has the exponent 1. And what is the index when there isn't an index? That little number on top of the radical? It's a 2. So what they taught you is to come from a radical into a fraction exponent. You would just drop this 2 underneath and the radical sign would go away. So I get 12 to the power of 1 over 2, right? So anytime you're given a square root function, you can actually write that number to the power of a half, because the 2 here that's in front, I'm going to erase that, the 2 that's in front can drop underneath the 1 that's on the 8, because every number has a 1 as an exponent, right? So instead of writing square root of 8, I can write it as 8 to the power of a half equals 2. Now, can I drop the 2 under the 8? No, it has an exponent. Can I take the 2 and multiply by the 16? No, it has an exponent. So what did I tell you to do? Write it to the power of 1 times 16 to the x plus 1. Now, what can I make them all be? I can make them all be base 2. 8 is 2 to the 3 to the power of a half. 2 is 2 to the 1, which is good. It's already done. 16 is 2 to the power of 4. ensuring to put your x plus 1 in brackets so you don't forget to distribute the 4 to all of them. So 2 to the 3 times a half, when your exponents are touching like that, you multiply. So I get 2 to the 3 halves equals 2 to the 1 times 2 to the 4x plus 4. Now I have two bases that are the same on this side. Remember, when I have two bases the same and I multiply, I add exponents. So I'm going to get 2 to the 3 halves stays that way on this side, equals 2 to the 1 plus 4x plus 4. So if you don't remember to put that 1 on the 2, you're not going to remember to add it on, and you're going to leave it as a 0. Everyone does it all the time, trust me. So I'm going to get 2 to the 3 halves equals 2 to the 4x plus 5. And now my bases are the same, so I can set my exponents equal. So I get 3 halves equals 4x plus 5. Subtract 5. Let me carry on up here. When I subtract 5, I'm going to get 3 over 2 minus 10 over 2, which is negative 7 over 2, equals 4x. And then I'm going to divide by 4. When I divide by 4, it's multiplying by a quarter, so I'm going to get negative 7 over 8 equals x. Once again, I can plug this into the original, see if left side equals right side, or I can go y1, y2. And if at any point in time you're stuck on that checking and verifying, please just email me. I'll help you. Okay? One last page. Just more practice. So these are you try. Okay, I want you to try these ones. So pause it and try it on your own. All right. So the first thing I would do here is I'm going to go 3 to the power of x equals 27 times 3 to the power of a half. Whenever I have that radical, that square root function, I'm going to turn to a half. Now I can't multiply the 27 by the 3 because it's to the power of a half. I can't divide the 27 over to the 3x because it's to the power of x. So I'm going to put it to the power of 1. Now I can make them all be base 3. So I'm going to go 3 to the x equals 3 to the 3 times 3 to the half. Now I have the same base on this side, so I'm going to have to add those exponents. I'm not going to get 3 halves, I have to add them. So I'm going to get 3 to the x equals 3 to the 3 plus 1 half. So if I have the same base, I need to add exponents. So I'm going to get 3 to the x equals 3 halves. 3 plus a half is 7 over 2. So x equals 7 over 2. And then we can check it with our calculator, y1, y2. Or I can just plug it back into here and see if left side equals right side. Okay, algebraically. Now e, if you've tried it, the problem here is the 8 to the power of 1, the 1 over 8. So I'm going to rewrite it as 8 to the negative 1, x minus 3 in brackets so I don't forget. Can the 2 join the 16? No, because the 16 has 2 to the x plus 1. Can the 2 divide over? No, because the 1/8 is to the x minus 3. So I'm going to write it as 2 to the power of 1 because it has to just be by itself. And then 16 to the 2x plus 1. So I'm going to get 8 to the negative x plus 3 equals 2 to the 1 times 16 to the 2x plus 1. Now I need to make them all the same base. I can make them be base 2. So 8 is 2 to the 3 to the negative x plus 3 equals 2 to the 1 times 16 is 2 to the 4 to the 2x plus 1. So I need to distribute my 3 in here. I need to distribute my 4 in here. So I'm going to get 2 to the negative 3x plus 9 equals 2 to the 1 times 2 to the 8x plus 4. So I get 2 to the negative 3x plus 9 equals 2. Now, remember, same base, and we're multiplying, so we have to add the exponents. So we're going to get 1 plus 8x plus 4. So we're going to get 2 to the negative 3x plus 9 equals 2 to the 8x plus 5. And now we have the same base, so we can set our exponents equal. Negative 3x plus 9 equals 8x plus 5. Add the 3x over. 9 equals 11x plus 5. Subtract 5. 4 equals 11x. Divide by 11. X equals 4 over 11. And you can verify algebraically or graphically. If you did graphically, you do this one and then this one. Please remember that exponents, if you're putting it into your calculator, exponents always need to be in brackets. Okay? And fractions always need to be in brackets. So that's it for today's lesson. Remember, if you are struggling on putting it into your calculator and getting the answer to verify it that way, or you're struggling checking algebraically, please just email me. I will help you.